Good afternoon, dear students. Yes, so previously we have completed alcohol, phenols, and ether chapter. Okay, so today we are going to start with the next topic. So this is the chapter that is chemical kinetics. Okay, it comes in physical chemistry of your second year chemistry. Okay, so So till now we have completed 5 chapters, okay, altogether for your PU2 syllabus, from your PU2 syllabus, okay. So this is the 6th chapter, that is chemical kinetics. So this comes under physical chemistry, okay. So let us start. So what is the meaning of chemical kinetics? Yes, can anyone tell me what we are doing in chemical kinetics? Yes, anybody? What do you mean by chemical kinetics? So it is a branch of chemistry which deals with the study of reaction rates. Okay, it studies the various reaction rates. Okay, and the factors affecting the rate of reaction and their mechanism. Okay, so what is chemical kinetics? So it is a branch of chemistry. Okay, so it is a branch of chemistry which deals with the rate of chemical reaction. So how the reaction is proceeding, at what particular rate it is proceeding. Okay, what are the factors which are influencing the rate of the reaction and how the reaction is taking place. Okay, what is the mechanism through which the reaction is taking place. So these are the factors which we are going to study in this chemical kinetics. Okay, in this particular chapter, chemical kinetics, we are going to study how it deals with a different rate of chemical reactions. Okay, how the different chemical reactions have different rates and how the factors. So what are the factors that will affect these rate of reaction? Okay, so firstly, we are going to study about the chemical reactions, okay, on the basis of rate of reaction. So these rate of reaction, it can be a fast reaction, it can be a slow reactions, or it can undergo a moderately slow reactions. Okay, so different, you have seen different chemical reactions, right? So these chemical reactions, so they will proceed based on, okay, so they may undergo a fast reaction. Some reactions can undergo very slow reaction, and some may undergo very like moderately slow, means very slow reaction. Okay, so that is moderately in between. So it can be a moderate reaction. So like that. So what is this fast or instantaneous reactions? Okay, so the reaction, chemical reaction, which completes in less than 1 picosecond. What is picosecond? 10 raised to minus 12 second. So when a chemical reaction, when it starts, okay. So how does this chemical reaction proceeds when, okay, reactants, okay. Okay. So, okay. So now, when a reactant, okay, reacts to give you products, okay. So what is happening? So a chemical reaction is occurring. Okay. So reactants are reacting to give you a product. So this chemical reaction, which completes less than, okay, it should be less than 10 raised to minus 12 seconds. Okay. That is a 1 picosecond. Then it is known as a fast reaction. Okay. Then these such type of reactions, they are called as what? Fast reaction. So such reactions are practically impossible. Okay, we can just say it by the okay, we can just say it, but it is practically impossible, and it is very difficult to measure also. If it is possible also, can we measure such reactions? Yes, less than 10 raised to minus 12 seconds. Okay, can you measure such reactions? No, it is very impossible. Practically, it is impossible. Okay, to measure the speed of such reactions. So what are the different reactions which can occur, like which comes under fast reactions or instantaneous reaction? So ionic reactions, okay, ionic reactions. Then neutralization reactions. What are ionic reactions? So when different ions combine, okay, when your cation and anion combine, so it forms a ionic this. So those are called as ionic reaction. Neutralization reaction means what? When acid and base combines, okay, when acid and base combines to give you what? Salt and water. Okay, salt and water. So this is another, so this is a neutralization reaction. Then is organic substitution reaction. Okay, what is organic substitution reaction? So suppose I have a substrate, okay, and I have a what I have a nucleophile. So what is happening? One of this atom is replaced by another. Okay, so you will get what? Ry plus X minus. Okay, so this is a substitution. So one atom is replaced or it is substituted by other atom. Such reactions are called as what? Organic substitution reactions. Okay, so we are discussing about the type of chemical reaction on the basis of rate of reaction. So there can be three types of reaction possible. One is a fast reaction. Okay, so in fast reaction, when a chemical reaction, if it proceeds less than, if it completes the reaction, if it completes the chemical reaction in less than 1 picosecond time, then they are known as fast reaction. Such reactions are practically impossible because we cannot measure the speed of such reactions. So what are the examples? Like ionic reactions, neutralization reactions, and organic substitution reaction. So this is about your fast or instantaneous reaction. Next is the slow reaction. Next is what? Slow reaction. Slow reaction means what? The chemical reactions, okay, which are when the reactants are reacting and to form the products, the chemical reaction, it is to complete the reaction, it is taking a very long time. Okay, if it takes a very long time, okay, suppose from some minutes to maybe some years together. Okay, so such reactions are called as very, that is slow reaction. So the reaction may complete in some minutes, maybe in 15 minutes, or sometimes for 2-3 years, like that. So such reactions, they are called as the slow reaction, which is taking very, very long time. Okay, suppose rusting of iron, rusting of iron is an example of a slow reaction. So rusting of iron does not take place within second or within a minute. Okay, it requires like a very long time. Okay, slowly the iron gets corroded when it comes in contact with the moisture. Okay, or it comes in contact with the air, and slowly it starts to get corroded. So this is called as rusting of iron. So slow reactions means what? The chemical reaction will not complete in a very slower time. It will take a very, very long time. Okay. So the example is rusting of iron. Then second example, I can give you transformation of diamond. Okay. So diamond, so to transform this, the transformation of diamond, it takes a very, like several years. Okay. You do not get diamond, like if you go to extract diamond, you will not get diamond like in a shiny surface. Okay, it will be very rough surface. So after polishing and also after undergoing a several methods, okay, refining and all, then you are going to get the shiny surface of the diamond. So diamond you do not get easily. Okay, with a shiny surface. So there is a different or like many like it requires several years together or several months together for transformation of the diamond. So such chemical reactions, they undergo very slow, uh, slowly, and thus they are called as termed as slow reactions. Okay. Slow reaction means what? Such reaction intermediate means what? In between. Okay, in between, not fast, not slow. So they are moderate. Okay, they are undergoing not very fast also and not very slow also. So they are undergoing at a very moderate condition. Okay, so moderately slow reaction. So such chemical reaction where they are intermediate between the fast reaction and the slow reaction, then they're called as moderately slow reaction. So what can be example of moderately slow reaction? Hebber's process. Okay, Hebber's process, that is Habers. Okay, Hebber's process. In Hebber's process, what we are doing? We are manufacturing ammonia. Okay, we are manufacturing ammonia. Now here we have Haber's process. Okay, this is Haber's process. In Haber's process, we are manufacturing ammonia, and this is Haber, Hebers. Okay, in Haber's process, we are manufacturing what? HI, hydrogen iodide. Okay, we are manufacturing what? Hydrogen iodide. So when hydrogen gas is bubbled over iodine, okay, you get hydrogen iodide. Okay, you get what? Hydrogen iodide. Okay, let us go for the next one. So these are the three different types of reactions. So fast reaction or instantaneous reaction, slow reactions or moderately slow reaction. So next we are going to study what is the rate of reaction. Okay, what is the rate of reaction? So what is this rate of reaction what we are talking about? Okay, so rate of chemical reaction, it is a change in concentration. It is a change in concentration or partial pressure of any one of the reactants or products per unit time. Okay, so this is termed as rate of reaction. So what is rate of reaction? So rate of chemical reaction is the change in concentration. Okay, when there is a change in concentration or partial pressure of any one of the reactant or product. Okay, per unit time. So this is the changes with respect to time. Okay, so then it is called as what? Rate of reaction. How it is expressed? It is expressed at, please remember the units. Units are very important. Mole per liter per second. Okay, mole per liter per second is the unit of rate of reaction. Okay, so how it is given as? So rate of reaction is equals to R, which is given as increase or decrease in concentration of reactant or product. So either it can undergo a increase or it can undergo a decrease in concentration of reactant or product. Okay, upon time taken. So this is with respect to time. Okay, how the rate of reaction, chemical reaction changes, whether it is increasing concentration or decreasing concentration with respect to per unit time. Okay, so then, so this is the, so it is given by dr by dt. Okay, it is given by dr by dt. So this is with respect to what? This is with respect to your so it can be plus or minus. So if it is increase, it will be plus. If it is decrease, it will be minus. So it is dx by dt. It is given by what? It is given by plus or minus dx by dt. So this is about rate of reaction. Okay, so rate of chemical reaction is what? It is nothing but change in concentration or partial pressure of any one of the reactants or products per unit time. So it is given by plus or minus dx by dt. So the change in concentration is with respect to time. Okay, and please remember the unit. It is mole per liter per second. Okay, so mole per liter per second, or it is also given as atm per second, atm per second, or it is given as Newton meter per square per second. Okay, so these are the rate of reaction given as. Okay, so this is the rate of reaction. Understood? Is it clear up to here? Yes?
Yes, ma'am.
Okay. So next we are going to discuss. So the rate of reaction, it is classified as average rate and instantaneous rate. So these are the two important rates. So the rate of reaction, it can be classified as what? Average rate of the reaction, which is given by small r average, and the instantaneous is given by r instantaneous. Okay, so this is the okay, how we denote it. So average rate of the reaction is denoted by RAV, and instantaneous rate of the reaction is given by RI instead. Okay, so what is this average rate? So the average rate of the reaction, okay, is defined as the change in molar concentration or partial pressure of reactant or product at a given time interval. It does not give the exact rate of the reaction. Okay, so this is average rate means what? It is defined as the change in molar concentration of reactant or product at a given time of interval. So this much also, if you understand, it is okay. Okay, do not study with respect to partial pressure. You can study what is average rate of the reaction, change in molar concentration of reactant or product in a given interval. Okay, in a given interval. Got it? Yes. Okay. So next is, if we, so how this average rate of the reaction can be calculated? It can be calculated by dividing the concentration difference by the time interval. Okay, so I'll show you. And generally, the rate of reaction is always taken as positive. So it is always taken as what? It is always taken as positive. So let me take here. So what is average rate? So remember what all things to be remembered. What is rate of the reaction? Okay, rate of chemical reaction is a change in concentration, okay, of the products or reactant per unit time. So this much also is enough. So if you do not uh, if you are getting confused, so do not okay, in the concentration of the reactant or product per unit time, the units are important. Okay, then what is rate of reaction? Rate of reaction is the increase or decrease in the concentration of reaction or product, okay, with respect to the time taken. How it is classified? It is classified as average rate and instantaneous rate. What is average rate? It is a change in molar concentration of the reactant or product in a given interval of time. Okay, so consider, suppose if I consider a, suppose, okay, suppose when the stoichiometric coefficient, so suppose if we have the stoichiometric coefficient, what do you mean by stoichiometric coefficient? Okay, I'll tell you. So N2 plus 3H2 giving you okay, so this is, so this represents the stoichiometric coefficient. Okay, so these numbers, okay, 1 mole, 3 moles of H2 and 2 moles of ammonia. So this represents what? This represents the stoichiometric coefficient. So suppose, okay, suppose what? When the stoichiometric coefficient of the reactants and products are same. Suppose the stoichiometric coefficient of the reactant and product, if it is same. So consider the reaction, that is reactant giving you product. Okay. And P1, They are what? They represent the molar concentration. They represent the molar concentration. Okay. Of what? Of reactant and product. Okay. Of reactant and product. At time T1. Okay. At time T1. So what is R and P? R is reactant, P is the product. So let R1 and P1 be what? Let it be the molar concentration of reactant and product at time T1. And what is R2 and P2? So let R2 and P2. Okay, what R2 and P2? They are the concentration. They are the concentration, molar concentration at time T2. Okay, so what is the change in time? So delta, that is time taken, is okay. That is change in time is T2 minus T1. Right? Change in time is what? Time taken. Therefore, time taken is T2 minus T1. What is change in concentration? How do we calculate the change in concentration? So change in concentration can be that is the change in concentration of reactant first we'll calculate. So if we calculate the change in concentration delta R, okay, delta R is equals to R2 minus R1. Okay, so this is the change in concentration of reactant. Now let us find the change in concentration of product. Change in concentration of product, that is delta P, okay, concentration of P, which is given as P2 minus P1. Okay, now rate of reaction. How do we write the rate of reaction now? Now we have to write the rate of reaction. So rate of reaction is given as what? Rate of reaction is given as R. So with respect to the reactant, it is delta R by delta T. So there is a change in this, so it is minus. Then similarly, the rate of reaction with respect to product, it is given as minus, that is, so product, okay, so what it is? So delta P upon delta T, okay, so delta P upon delta T. So this is with respect to the product. Got it? So the rate of reaction is expressed in terms of reactant and negative side. So for the reactant, it is expressed in what? The rate of reaction for the reactant. Okay, reactant will be on left hand side. So that will be always negative. Okay, negative sign, what it indicates? It indicates the decrease in concentration of reactant in a unit time. So always, okay. And your product will be positive. So your reactant will be always given a negative sign, and this negative sign indicates the decrease in concentration of reactant in unit time. So this is the when you have psychometric coefficient of the reactants and products are same. Okay, so when the psychometric coefficient of the reactant and product are same, so that time the rate of the reaction is given like this. Okay. So what all we have done, we have seen the chemical reaction is proceeding from R to P, that is from reactant to product. Okay. So let R1 and P1 be the molar concentration of reactant and product at time T1. Let R2 and P2 be the concentration of time. Okay, with the concentration at time T2. So what is change in time? Change in time is T2 minus T1, and change in concentration of reactant, it is given as delta R, that is reactant, concentration of reactant is equals to concentration of R2 minus concentration of R1. Then change in concentration of product, it is given as delta concentration of P is equals to concentration of P2 minus P1. So when we write the rate of reaction is given as minus delta R. Okay, minus delta R. So this is R should be written in concentration. So it will be like this. And here, okay, delta R minus delta R. And here, that is by dt, that is by with respect to the time. And rate of reaction is given as product, rate of reaction of product is given as delta of concentration of P upon delta T. Okay, so this is with respect to what? This is with respect to your rate or reactant and product. Okay, so rate of reaction with respect to of reactant and product. Okay, So negative sign is always given for reactant. It indicates the decrease in concentration. So let us see the graph. So this is the concentration of reactants versus time and concentration of product versus time. So these are the two graphs, okay, which you can see. So here, this is your R naught. Okay, this is your R naught, concentration of R naught. This is concentration of R1. Okay, and this is concentration of R2. And this is at time T1, at time T2. Okay, so this is the delta T, that is a change in time. Okay, then here this is P2 and this is P1. Okay, and this is the change in, this is the change in delta P, that is the change in delta T, that is in time. So this is the what? This is the graph. Okay, this is the graph which represents your average rate. Okay, when we write the average rate, so this is the condition. Now suppose, so how to write the average rate? Suppose I give you, suppose I give you a question like this. Write the expression, write the expression for the rate of reaction, for the rate of reaction of Hg liquid plus Cl2 gas, giving you HgCl2 solid. So how will write the average rate of the reaction? So average rate of reaction. Okay. So average rate of reaction is given as what? So this is your reactant and this is your product. So let us write. So minus delta concentration of Hg by delta T, okay, with respect to time is equals to, okay, minus delta, okay, Cl2, concentration of Cl2 by dt is equals to, then your, we know that for reactants it will be negative sign. Okay, so for both the reactants I have written the negative sign. Then for your product we are not going to write the negative sign. So this is the average rate of the reaction. So whenever if they ask, if they give you any such equation or expression, and if they tell you to write the average rate of the reaction, so for the your this what, for your reactants you have to mention the negative sign, and for your product you should not mention a negative sign. Okay, so this is with respect to when you have the stoichiometric coefficient of the reactant, and this is same. You can see everywhere it is 1, right? So the stoichiometric coefficient of the reactant product is same. Okay, so this was the case 1. Now let us see case 2, where you have stoichiometric coefficients of reactant and product are different. So when the stoichiometric coefficient of product and reactant are different. Example 2HIG, 2HIG giving you H2 gaseous plus I2 gaseous. Can you tell me the stoichiometric coefficient? What are the numbers? What are the stoichiometric numbers here? Yes. So here the stoichiometric coefficient of the reactant and product are different. So HI is 2 moles. This is 1 mole and this is 1 mole. So you can see that in the reactant and in the product, the number of stoichiometric coefficient are different. Okay, so what we have to do? So you can see that we get 1 mole of H2 or I2. Okay, so the rate of composition consumption of HI is twice the rate of formation of H2 or I2. So for every 2 moles of HI, we get 1 mole of H2 and I2. Right. So in such a cases, what we have to do, the rate of reaction is obtained by dividing the rate of change of concentration by stoichiometric coefficient. Okay. So how you are going to write the rate of reaction? So rate of reaction is given as, so we have to multiply. Okay, what we have to do, we have to divide. Okay, we have to divide the rate of the change of concentration by the stoichiometric coefficient, okay, of the reactant or product. So the rate of reaction, so the rate of reaction, it is given as what? So what is the stoichiometric coefficient here? It is 2. So it is minus 1 by 2. Okay. Then delta Hi by dt is equals to, okay. So delta H2 by dt is equals to delta I2 by dt. Is it clear? Got to know? Sorry, not dt. We'll write it as delta T only. Okay. So this is H2 delta T, that is change in time. Okay. Yes. Did you get it? Yes. Did you get it? How to write? Yes.
Yes,
So
ma'am.
we have seen two cases. One case where the stoichiometric coefficient of the reactant and product are same. Okay. How to write the average rate of the reaction. And the second case where you have the stoichiometric coefficient of the reactant and the product are different. So how to write the rate of the reaction. So this way we are going to write the average rate of the reaction. I have another example, N2 gaseous plus 3H2 gaseous giving you 2NH3 gaseous. Okay. Can you tell me how to write the average rate of reaction? Somebody? Yes, anybody? How will you write now? You can see the stoichiometric coefficient. Here it is 1, here it is 3, here it is 2. So how we are going to do? We are going to take the stoichiometric coefficient and we have to divide it. Okay, by dividing by taking and by doing the rate, dividing the rate of change in concentration. Right. So how we are going to take? So it is minus delta N2 by delta T is equals to, okay, on the reactant side, we have to mention everywhere minus, right? So minus 1 by 3 delta H2 by dt, sorry, not dt, by delta T is equals to 1 by 2 delta NH3 by delta T. Got it? So this is plus. Okay, here it will be plus. On your left hand side, it will be minus, and here it will be plus. Got it? Yes.
Yes, ma'am.
So, generally, if we have AA, BB giving you CC plus DD, suppose this is the stoichiometric coefficient. So generally, how we are going to write generally? So it will be the rate of reaction. Rate of reaction, it is given as what? Minus 1 by A. Okay, 1 by A, concentration of A by delta T is equals to minus 1 by B, concentration of B by delta T is equals to plus 1 by C, concentration of C by delta T is equals to plus 1 by D, concentration of D by delta T. Understood? Yes. C. So this is generally. Okay, this is generally, let it be any number. So when the stoichiometric coefficient is different, so we are going to apply like this. So average rate of the reaction, we have seen two cases. One where the coefficient, the stoichiometric coefficient are same, the numbers are same. Another condition where the stoichiometric coefficient, the numbers are different. Okay, the reactant, the stoichiometric coefficient of reactant and products are different. Okay, is it clear? So these two conditions. Okay. Now, I'll give you a equation. You have to tell me. plus Br23 minus aqueous plus 6H plus aqueous, giving you 3Br2 aqueous plus 3H2 liquid. Yes, anybody? Anybody? So how will you write the average rate of reaction? Now, till now, you should be perfect. Okay, I have taken many examples. You have to be perfect. So on this, you have to take minus sign. Here, you have to take plus sign. How will you write? So this will be, yes,
Minus
start. Minus,
1 by 5
yes. Concentration of Br
PR
minus upon
divided
delta
delta
T.
T
Okay, is equals to
minus
minus delta. Okay, there is no number. So don't write 1. So delta
concentration
Br is concentration. So here delta I forgot. So Br O3 minus, okay, by
delta
delta T is equals to
minus 1 by 6
minus 1 by 6
delta
delta H plus by delta
delta
T. Yes, is equals to,
plus
yes, plus 1 by 3 concentration of Br2 by delta T is equals to plus 1 by 3 delta B concentration of water by delta T. Yes, very good. So like this. Okay, so like this the question is asked. So they give you the equation and they will tell you to write the average rate of the reaction. So like this the question is asked for 1 mark. Okay, so like this the question is asked for 1 mark. Got it? Okay, so this is about average rate of the reaction. Is it clear? Both the cases are clear? Yes. So we have seen the chemical reactions. Okay, what are the 3 different types? Then we have seen what is rate of the reaction. So the rate of reaction is classified into 2, average rate and instantaneous rate. So we have seen what is average rate. Okay. Okay. Next is the instantaneous rate. Okay. Next is what? Instantaneous rate of reaction. So what is this instantaneous rate of reaction? So instantaneous rate of reaction. So instantaneous rate of reaction. Okay. So the rate of reaction at a particular instant, okay, of time, it is called as instantaneous rate. So please note it down. So rate of reaction at a particular instant of a particular instant of time is called instantaneous rate. Okay, it is called as what? Instantaneous rate. Got it? So what is instantaneous rate of reaction? So rate of reaction at a particular instant. Okay, at a particular instant, it is called as instantaneous rate of reaction. So how it is obtained? It is obtained by average rate of the reaction. Okay, by considering the smallest interval of time dt. So, so let us see. So mathematically, so we write that is rate of average reaction. How it is given? Minus delta, okay, concentration of this into delta T is equals to delta concentration of P by delta T. So this way what we write, this is the average, right? The rate of the reaction, if I write rate is equals to that is reactant giving you product. So I want to write the average rate of that. So I'll write it like this. Now, when your delta T is approaching 0, that is when we are writing the this what instantaneous rate. So instantaneous rate, it is when your delta T approaching 0 is not equal to 0, it is approaching, okay, is approaching 0. Then our instantaneous is given as minus, okay, minus d by r upon dt is equals to d by p by dt, okay, so which is equal to the slope, which is equal to what? Which is equal to the slope. So instantaneous rate of reaction, it is obtained by graphical. Okay, you can take a graphical. So this is your. So here you can see. Just a second, I'll show you the. Okay, so your instantaneous and this. So how you can calculate? So graphically, your slope. Okay, this slope, what it represents? It represents your instantaneous rate. Okay, it represents your instantaneous rate. So rate instantaneous is given by minus d by that is d by a concentration of r by dt, which is equal to the slope. Okay, and what is the other? So here the slope. So this represents your what instantaneous rate. Okay, instantaneous rate. So our instantaneous is given as what? It is given as dr by dt is equals to slope. So slope represents your what? The slope will represents your instantaneous rate. Okay, so that is when your limit, that is your delta t, when it is extended to 0, your concentration will be dr by dt. It becomes dr by dt. Okay, now we'll see the so this is with respect to the instantaneous rate. So instantaneous rate, how it is obtained? It is obtained graphically. Okay, by drawing the tangent. So after drawing this tangent, so here there is a tangent is drawn. Okay, here also you can see a tangent is drawn. So from this tangent, what we are going to get? We are going to get the curve of the concentration of reactants or product against the time and calculating its slope. So after calculating its slope, we are going to get the what instantaneous rate. Okay, so this is about your instantaneous rate. Is it clear? So like this, we are going to calculate the instantaneous rate. Okay, so let us see. So this was about your instantaneous rate. So let us see two questions. Okay, so in a chemical reaction, uh, in the chemical reaction, initial initial concentration of reactant is 1.0624 mole per liter. After 80 seconds, the concentration decreases, okay, to 1.06 mole per liter. Calculate the rate of reaction. Okay, calculate the rate of reaction. How will you going to calculate it? Yes, so the change in time. Okay, first the change in will take concentration. So the change in concentration, is given as delta R. Okay, that will be 1.06 minus 1.0624. Right. So that is minus 0.0024 mole per liter. Right. Now what is the time taken? What is the time taken for this change? It is 80 seconds. Okay, it is 80 seconds. So how will you calculate the average rate? So average rate is equals to, yes, it is minus delta R by minus delta T. Okay, that is delta T. Yes, substitute. See what answer you will get. Yes. So minus of minus 0.0024 mole per liter divided by change of time is 30 second. Yes, see how much is the average rate you are going to get. So here the initial concentration is only given of reactant. So we are calculating only for reactant. Yes. How much you are getting? Just check. So it will be 3 into 0 point, yes, correct. Baby has answered. So I can do it 3 into 10 raised to minus 5 mole per liter per second. Okay, what I'll do, how much you got? You said it is 0.00040 zeros and 3. So if I shift the decimal 1, okay. So if I shift the decimal 1, 2, 3, 4, 5, okay. So it will be 10 raised to 5. So, okay. So I am shifting the decimal to fifth point 1, 2, 3, 4, 5. So it will be 10 raised to minus 5. Okay. Got it? So like this, we are going to find. Got it? So is it clear? Is it clear? What is the rate of reaction? What is the average rate of reaction and what is instantaneous rate of reaction? Yes. Is it clear? Yes. Okay. What about others? Baby has understood. What about others? Okay. Good. Okay. So there are two more problems. So there are two more problems. Okay. We will do in the next class. Okay. So two more problems are there. And then we are going to discuss about the factors which are affecting the rate of the reaction. So, okay. Any doubts? Any doubts up to here?
No, ma'am.
Okay, fine. So, please go. So, I have uploaded the notes of alcohol, phenols, and ethers. Okay, please go through the notes. Okay, and also please study about chemical kinetics and come in the next class. Okay, fine. So, thank you. Have a good day. Okay, I shall end the session here. We will meet in the tomorrow's class. Okay, tomorrow we have a class. So, tomorrow we'll meet. Okay, so thank you. Yes.